So let's begin with the basics, the fundamentals of blockchain. What is a blockchain? So we'll cover the basic terms, the history of blockchains, what makes them unique, and how they operate in this section before we move into more details of the economics. First, a block has a timestamp, transaction details, information of the sender and the receiver, and every time a new block is added to the system, it is linked to a previous block, creating a chain in the process, hence the word blockchain. And then there's a level of math, cryptography, and more equations that are happening behind the scenes that ensure that there's a transaction is secure, that it's accurate, and the most important piece, which we'll expand on, is that thousands of computers, or what are called nodes, are actually all doing these calculations at a certain point in time. They're all fact checking each other. So the way they do this is behind the scenes, and that creates a trustless system because you're trusting the computer and the software to deliver accuracy. And we'll talk about the economics in the next section about how this is important over a period of time. So each block is verified. There's a node that's verifying it. As I mentioned, it's being confirmed. But to do that, you need to, if one answers a specific, you solve a specific problem, which in this case is a computational problem. We're looking at a hex version with, for specifically here, the Bitcoin Genesis block, which I'll break down later on, why this is important, how it was created, and the significance of it in the history of blockchains. And then what we do every time we do a transaction on chain, which is the term you'll find me using quite often, we talk about creating a system of record. So this is a source of truth. Instead of everybody having their information siloed on specific computers that either they own or centralized on a cloud at some server in some storage facility, all the computers in the world are agreeing to one source of information, in this case, a system of truth, and then it creates an opportunity for people to own their data. I mean, you plug into the world's supercomputer, and then that's your access point. You no longer have to worry about your phone or your laptop or your login to be your access point through another third party. So this is what makes the blockchain unique. It creates a lot of transparency without a central authority, hence the portion of decentralization, and removes the middleman, reducing the risk across the system. So you own your information. We'll talk about how that is done in a later section, but it's important to note right now that transparency and no central authority or party is controlling your information. So, what are the advantages of the blockchain? First is decentralization and transparency. This is something we've already discussed. The third parties, getting rid of them, reducing the possibility of a single point of failure, um, such as a large bank, which we've seen in the past bailout during the great financial recession, or centralized intermediaries. The disadvantages are a little bit more complex, specifically relating to the mathematical formulas, the computation required, the hardware or software required to implement these blockchains. And the biggest one, usually, that people are least familiar with is immutability. We'll talk about what this means in specific chains, but immutability is the immutable means that the records are saved and recorded and they cannot be reversed. So once a transaction is completed, you don't go backwards in time, you go forward in time to make changes. And to make a change in the future about a past transaction requires a lot of parties to agree on a transaction. So one, it's great to create security and to create that level of trust, but it's difficult to go back in time and to change what happened. So it's a catch 22. There's a lot of advantages to have that. There are a lot of disadvantages, and it should be clear or at least known. So here's the scalability trilemma, or I call it the blockchain trilemma. The three portions of this triangle are scalability, security, and decentralization. I'll talk about the different angles of these when we go into different forms of cryptocurrencies, but here's a little breakdown to get familiar. You can see Bitcoin and Ethereum on the top left of the triangle. Um, they optimize for decentralization and security. Other chains optimize for other portions of this triangle. And the challenge today is that nobody has solved for all three of them. So we'll talk about what this means, why it's important, and how you can use this information to either invest or to understand the industry. So far we've mastered the fundamentals. Every block, as we discussed, is linked to a previous block, creating a chain in the process, hence the word blockchain. These blocks are verified at each step by thousands, hundreds of thousands of other computers, creating the world's system of records, or in some cases, the world's computer. And then these blockchains, each blockchain has a different problem it's facing. So in the blockchain trilemma, we got decentralization, scalability, and securability. These are areas that we look for to solve in the blockchain.